The lesson topic for this video is zeros of polynomials. Now let's remember that a zero of a polynomial is another word for solution. So we are going to find the solutions of the polynomial, and the solutions are found where y equals 0. So it's our x values when y is 0, which means we are going to, if we're going to find all the solutions, we're going to put a 0 in for y, in this case f of x, and we can rewrite this. And our job is to find all the solutions or zeros of the polynomial. Now, we've been working on this, so this will be nothing new at first. If you look at this one, we've got a 4-term polynomial that we can solve by grouping. So we're going to put that vertical line down there, and we're going to go ahead and factor out the GCF on each side of that line. In this case, x squared, and we're going to be left with x minus 3. And then on the right side, we've got -9 that we can factor out. Make sure you include the sign. And we're going to be left with x minus 3 as well. And that's good because now our parentheses match. So our next step would be to write 0 equals, and we've got x minus 3 that we can factor out. And then we're left with, once we factor these two factors in the parentheses out, we have x squared minus 9. X squared minus 9 goes here. And we are not done factoring yet because we can see that this is a difference of squares. So we will keep going. 0 equals x minus 3. And then this will be two sets of parentheses. X times x is x squared. And we need a 3 times 3. And one is positive and one is negative. Now we will use the zero product property to say that if these three things multiplied together gives you 0, one of those three factors must be 0. So x minus 3 equals 0, or x plus 3 equals 0, or x minus 3 equals 0. When we do our math, we're going to get our solutions here. And you probably noticed something. We're going to get x equals 3, x equals negative 3, and x equals 3. What you see here, technically it says there's 3 solutions, x equals 3, negative 3, and 3, but these are what we call this is what we call a double zero. Okay, a double zero is when you get the same zero or solution when you solve. So 3 is a double zero. 3 is a double zero, so it is one of our solutions, and then negative 3 is our other solution. So we could write that our solutions are 3 and negative 3. Okay, x is equal to 3 and negative 3. The fundamental theorem of algebra, which I will talk about on the next screen, says that if we start a problem that is a third-degree polynomial, which this one is, then we will end up with 3 solutions as long as you count any double zeros or triple zeros, etc., as many times as you see them. So you'll notice here we have 1, 2, 3 solutions. If we count the double zero twice, 3 solutions. It's a third-degree polynomial. That is what the fundamental theorem of algebra tells us. So, like I mentioned on the previous page, the fundamental theorem of algebra says if f of x, which is a function, right, is a polynomial with degree n, then the polynomial will have n solutions as long as you count the repeated solutions more than once. So if it repeats, you count it as many times as you've got it, and then that degree will always match the number of solutions you have. So in other words, an nth degree polynomial will have exactly n solutions. So this is important because as you're solving, if you end up at the end of the problem saying, oh, x equals 5 and x equals negative 3.487, yet the degree is 4, then you know you've missed something along the way and you need to find your additional 2 zeros or solutions because it's a 4th degree polynomial. So if you look at the example right here, it says find the number of solutions or zeros, and it's as simple as, again, if the polynomial is written in standard form, which they typically are, it will be the highest exponent on your leading coefficient term. So this will have 5 solutions, this will have 4 solutions. That is what the fundamental theorem of algebra tells us. Okay, so let's try this example. Find all the zeros of the polynomial function. Let's think ahead here and decide how many solutions we should find when we're finished with this problem. And the answer is we should find 3 because it is a third-degree polynomial. All right, so to find a zero, again, a solution is where our x-intercepts are, which is also where y is 0. So we're going to put a 0 in for y, or f of x. And we have our polynomial. And just like the previous example, it looks to me like we can factor this by grouping. So if we put this vertical line down right here and factor each side, over here, the most we can factor out is 1. So we're factor out a positive 1. Notice our parentheses match, so we're going to go ahead and write that factor, x minus 3. We factored that out, and we're left with x squared plus 1. Now, question, is this factorable? The answer is no, it is not factorable because it is a sum of two squares, not a difference of squares. So that will never factor. If it doesn't factor, we keep going by solving using the zero product property. So we're going to get x minus 3 equals 0, or x squared plus 1 equals 0, and we solve our equations. I'm going to add 3 to both sides, and we get x equals 3. So there's one of our solutions. Over here, we're going to subtract 1 from both sides, and we get x squared equals negative 1. And now we are going to square root both sides. Now I'm going to make an error here on purpose. I'm going to say x equals the square root of negative 1. Well, you might think, oh, that's going to be imaginary, and that's true. So the negative would mean we have an I situation, and the square root of 1 then would be 1. So we actually have like 1i, or I1, whichever way you want to write that. Now I made a little mistake there on purpose, you might have noticed. Let's think for a second. If I said there should be 3 zeros, 3 solutions, why do I only have 2? That's the kind of questions you need to start asking yourself. Well, the answer is that when we square root both sides, what do we have to remember to do? We have to remember to include a plus or minus, a positive or negative, in front of the 1i. So we do now have 3 solutions, x equals 3, x equals positive 1i, and x equals negative 1i. And those could, of course, just be I. And there's our solutions. 3 solutions for a third-degree polynomial. Okay, so here's one more example. And do what you'd like here. If you'd like to just watch me walk through it, great. If you'd like to pause the video, try it on your own, and then check back to see how you did, that's great too. This is going to involve a lot of different stuff that we've been practicing. Okay, find the zeros of the polynomial function. Again, the zeros are when y is 0, and now we are going to start this problem by thinking about how we use a graphing calculator in order to find our first zero when we have a situation like this. So we are going to use synthetic division. Double check that you're not missing any terms. So x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, x to the 0, or our constant. So we're good. So 3, negative 10, 1, 20, and negative 12. In order to use synthetic division, we need to go to our graphing calculator. When you go to your graphing calculator, you are going to find a graph that intersects. Now make sure you're putting the equation right here in there. We are going to find an x-intercept at 2. So we're going to go ahead and put 2 out here. I guess I will show you this graph here. So here's the graph. If you notice, we've got what looks like an x-intercept there, and there, and there. Now if you check those out, you're going to find that the only one that is actually a whole number is the 2. Okay? So if you use trace and hit trace, and it looks like maybe it goes through 1, trace 1 will tell you that it is not going through positive 1 nor negative 1. All right, so we have 2. We're going to go through our synthetic division steps. Bring the 3 down, multiply, add, multiply, add, multiply, and add, and multiply, and get a remainder of 0. So that's good. All right, so we're going to write 3, and we're going to drop our x to the fourth right here. We're going to drop that down to x to the third minus 4x squared minus 7x plus 6. Once again, I'm going to look at this polynomial and see if we could factor by grouping. If I put this vertical line here, we're not going to get the same thing on either side. That tells us we're going to need to use our synthetic division steps again. So we're going to put our synthetic division down. 3, -4, -7, and 6. Double checking again. X to the third, x squared, x, and x to the 0. Now we need another x intercept. Again, look at the graph to the right, and we realize that, again, -1 and +1 don't work, so where's another x intercept? Well, I'm going to take another picture of my calculator after I change my y equals on my calculator, go to y equals, and put this new equation here after we factored out this 2. Okay, so I'm going to put this in my calculator. Okay, so here is a screenshot of my new graph after I changed it to this expression. Notice again, that is not at -1, this is not at +1 if you check those with trace, but this x-intercept right here is at 2. So we are going to use 2 for our divisor, and we are going to follow through our synthetic division steps again. Notice we get a remainder of 0 again, so that's good. And we're going to write 3x squared, again, this x to the third power gets brought down to x squared, plus 2x minus 3. Now at this point, we have got a quadratic, and if you think about trying to factor this quadratic, you'll get a magic number or term or AC method. You'll get -9x squared, and you know that -9 is not going to help us arrive at positive 2x in the middle. That tells us we are going to need to use the quadratic formula. Okay, so I'm going to just move our graphs up here to get out of my way. We're going to use the quadratic formula with 3x squared plus 2x minus 3. All right, after we fill in A, B, and C, keep doing the work here. Get the square root of 40. And then if we do our computation, we're going to do -2 plus the square root of 40, hit enter, and then divide that by 6. And we're going to take -2, subtract the square root of 40, and then divide that by 6. Again, nothing new here. We're going to get 0.721 and -1.388. Okay. So what does this all tell us? What is our final answer? The question is find all the zeros of the polynomial function. So the solutions are 2. We found that one on our graphing calculator. It is a solution, or a 0. 2 again, and then x equals 0.721, and x also will equal -1.388. There are 4 solutions, as there should be because it's a 4th degree polynomial, as long as we count this double solution twice. So we've got 1, 2, 3, 4 solutions. Now if we look back at the original graph here, if you can kind of see through that writing a little bit, you will notice that that is at where our solutions are. So this solution right here is the -1.388. The solution right here is the 0.721. And the solution here is the 2 that happens to be a double 0. So that's our 4 solutions found in our function, in our graph.